please join again. So let's start with today's topic. So today we are going to study how to use the heap for sorting. So that method using heap for sorting is known as a heap sort. Okay. So basically what we are going to do is, given an array like this, the elements to be sorted are stored in an array. Name of the array is ARR, and we are starting from index 1. Okay. Why? Because the binary tree, like I told you, representation starts from index 1. Okay. So can you all, looking at this array, draw the binary tree? We have studied binary tree representation using arrays. So in that, binary tree was given to you and you have to store the elements in the array. This is opposite now. The array has been given to you. So can you draw the binary tree? You know the formula that we had discussed yesterday. Okay. That if there is a node at I, then the left child will be at present at 2I. So the left child of I will be present at 2 into I, and the right child of I will be present at 2I plus 1. So using this, you can construct this tree from this array. So I hope you have been able to draw. If you have been able to draw, then this will be what you will be getting. Okay. So like I told you, this first element, it just like we have done the opposite. Used to be given the satisfies the properties of a heap. So check the first property, that is the structure property. Check whether your this tree that is present here satisfies the structure property.
Hello, sir.
Yes.
So your audio went after you showed the tree.
Okay. Okay. Can you hear me now?
Yeah, sir. Now we can hear.
Can you hear? Okay. So what I was telling you was, basically previously when we were learning trees, you were given this tree. Okay. You were given this tree, and then you were told to put it in the form of a. So in this example here, you have been given the array, okay, and you have to put it in the form of a tree, a binary tree. So this is how you would have done it. Does anyone not know? Does not know how we got this? Please tell me. I can explain it to you all. Anyone who does not know how I got this tree from this array? Is it okay with everyone? Everyone knows? There are around 51 students, so everyone knows how this tree is come about. Okay, so then if you know, then next we have to continue. So first of all, identify whether this tree that you have drawn, is a heap. So if it is a heap, it will have two properties. One will be the structure property, and the second will be the heap order property. So check whether both properties are satisfied. Now when we are doing this heap, like I told you, this heap should be a max heap. So basically we are checking heap order property for a max heap. Okay. First check whether the structure property is satisfied. If it is satisfied, then check whether the second property is satisfied. So you can type your answers in the chat. Are both properties satisfied? Okay. Only the first one is satisfied. Second property is not satisfied. Yes, correct. Okay. Second property is not satisfied. That is, it is not a max heap. Okay. It is not a max heap. So now you need to make it a max heap. Okay. You need to make it a max heap. So basically what you're going to do is to make it a max heap. Again, the method is very simple. Okay. You're going to start from here. Compare with its parent. Compare with its parent. And then you know that in a max heap, the value of the parent should be greater than the child. So after comparing, if you find that value of the parent is less than the child, exchange the values. Okay. So once you exchange this value, you go to the next element. Compare with the parent, and so on. After you do this two, then go to the next one, then next one. Then after you finish this row, start again from here. Compare with its parent. Okay. Once you do that, compare here. So like that you have to continue till you reach to the root node. So basically what you're going to do is start from the end here, the last element. Once you make the heap proper between these two elements, you come here, check these two elements, and so on till you finish this last row, the last level. Once you finish the last level, and on this level, you start from here again. Compare with its parent. Then once you finish with that, come here, and so on. Okay. So I'll show you in the next slide how that is to be done, what I just told you. So here you can see. Okay, first I start from here. I compare 46 and 95. Since it is not proper, I exchange these two values. Okay, I exchange these two values. After exchanging, I get here like this, 46 and 95. Then I can compare 12 with 95. Everything is fine, so I don't change anything there. Okay. Then I come to this element, 78 and 9. When I compare, I find that there's a problem. It's not a max heap. Okay. So I exchange these two values, 9 and 9. Proceed. I compare 23 with 78. So it's proper 18. Okay. So when you compare 48 with 18, 48 will go on top, 18 will come down. Then you will compare 70 with 48. So when you compare again, you find that there's a problem, that this is not proper. So you will swap. So after swapping, you get like this. Okay. So basically what they have done here is, okay, if you look in this slide here, they are comparing both the children simultaneously with the parent. Okay. So now you can see that these both values are greater than the parent. So instead of swapping two times, they swap only the maximum value with the parent. So instead of swapping two times, they're swapping 70 with 18. So swap. You're going to do. So instead of checking individually, you can take two children like this at the start. Okay. Compare with this parent. Now this one is less than the parent, so you're not going to touch this 12, but 95 is greater than 46. So swap this 95 with 46. So when you swap 95 with 46, you will get this 95 here, 46 here. Then you take the other next two children of this node, okay, compare. So the maximum value of the children, whichever is greater than the parent, that value you will swap with the parent. So among 23 and 78, both are greater than 9, but 78 is greater than 23. So you swap 78 with 9. So you will swap this and this. Okay. So like that you have to keep swapping till you get a maximum heap. So finally you will get this max heap here. When you do this swapping, you will swap 70 with 18, because although 70 and 48 are both greater than 18, 70 is larger or greater than 48. So 70 and 18 is swapped and you get 70 here and 18 and you have 95 and 35. Okay. So after swapping 95 and 35, you will get 95 here. You will get 35 here. When you get 35 here, you will see that 35, which is at 46. So here a double swap takes place. Okay. So once you do that, you compare these nodes and you find the greater child of 25 is 95. So you exchange this 95 with 25 first. So when you exchange, you will get, when you exchange, you will get 95 here, okay, and 25 here. Now when you compare this 25 with its children, you will see that this value swap 25 with the greater child. You will swap 25 with 78. So when you swap, it looks something like this. So originally you were comparing only these nodes, but when you did the swapping, this here a problem was caused. Max heap property did not remain here. So because of that, we had to do double swapping. Okay. So please note, sometimes you may have to do two or more swappings in order to get the max heap property. So can you all just, if anyone has any doubt in any of these diagrams, like I'll just number them here: 1, 2, 3, 4, 5, 6. So if you have any doubts in any of this diagram, you want me to explain how it is happening, you can just let me know in the chat. So if anyone is not understanding what has just happened here, you can let me know in the chat. Did you get this? How we got a max heap? Basically, we have converted this array that was given into a max heap. First, we converted it into a binary tree, and this binary tree, when we found that it is not satisfying the property of a heap, we have converted it into a max heap. Okay. So, any doubts in any of these diagrams that we have here? Here, the 6 diagrams. We can either all of you have understood or you are not understanding. Just give me some feedback. Have you all understood? Okay. Okay. Then let's proceed. So basically, our aim was to do heap sort. We need a max heap. So your whole aim of doing this thing was given an array to you. The array may be given to you or it may not be given. It could be just given like this also to you, some elements. So in the exam, if you're given some elements like this, or the binary tree heap. Okay. Once you have got the max heap, then we can start with this thing known as heap sort. Okay. You could have also done a min heap also, but like I told you in your textbook, we are studying only max heaps. So we are converting it into a max heap. In the exam, you may be told to make a min heap. So please read your questions properly. So this is what we have done basically. Given an array of elements, we converted to a max heap. And once we have converted to a max heap, again I have represented this max heap in the form of an array. So the elements are stored in an array. I have numbered this max heap. This max heap, whatever we had got in this 6th diagram. So I have numbered it. After numbering it, I have stored the elements in an array. Okay. You could use the same array or you could use a different array for storing. Okay. So once I have done this, I'm going to now start with my sorting. Okay. So I can sort in ascending order or descending order. Okay. So for sorting, I use the deletion. Yesterday we had studied deletion and we use that deletion for sorting. So basically what we are going to do is, I'm going to delete this root node. So I know that the root node contains the maximum value. So I'm going to delete this root node. Okay. And I'm going to store it at the end of the array. So you know that after I delete 95, which value will replace 95? Can I type in the chat? You've already seen this. Looking at this diagram, when I do the deletion in a heap, if I delete 95, which value replaces 95? You can type in the chat. Yes, correct. 35 will be replacing 95. Okay. Now, 35 will be replacing 95. Correct. So once you replace, that is, once you delete 95 and 35 is your new root, is your tree or is your heap still satisfying both the properties? It is still satisfying both the properties. If not, you need to reorder the heap. Okay. Please pay attention and write it down what I'm saying. So whenever you're going to sort this heap now, see your first step, let me repeat it again, what you're going to do when you get a heap sort. You will be given a set of elements. So you're going to store it in an array. Once you store it in an array, you're going to represent it using a binary tree. Once you draw the binary tree, you will check for the properties of the heap, both the properties. If any one of the property is not satisfied, mostly the first property will be satisfied. Okay. So if the second property is not satisfied, then we have seen how it is to be made into a max heap. Okay. So once you have made a max heap, you represent that max heap using an array. Once you have done that, you can start with the actual heap sort. So the heap sort will be, you're going to keep using the delete function. You're going to delete the root node. So when you delete the root node, you know in the max heap, you delete the maximum value and you replace it with the leaf node here. You're going to basically replace it with 35. And when you replace it with 35, you will see that the property of the heap is not satisfied. That is your second property. Okay. So then you need to reorder the heap. So basically, we are going to start now with heap sort. Okay, so you can note down this if you want. This is your first step wherein you have represented it in the form of an array. Okay, so in the second step, I'm going to delete 95 and replace 95. Okay, now when I replace 95, I will get here 35. I'll get here 35. And obviously 35 will not be present here. Okay, so when I get 35 here, check for both the properties of your heap, the structure property and the heap order property. If any one of these properties is not satisfied, reorder your heap so that it becomes a max heap. So please do this. If you feel any of the property is not satisfied, then reorder. So can you tell me now, right now in the chat, is it satisfied or not satisfied, and which property is not satisfied? Yes, students, once you get 35, second property is not satisfied. So can you all reorder it? Can you all make it a max heap? Can you all make it a max heap? You have to do all these steps like I told you yesterday. These steps, I'm just showing you that yesterday's slide. You were deleting 90. So I replaced 37 here. I got 37 here. Now we saw that it was not a max heap. Okay. So in order to make it a max heap, I did all these things. You need to do now all these things. You have correctly told me that when you are having 35 as a root, it is not a max heap. Okay. So now you please do all these steps, so that you get a max heap. You need to do that. I'm not going to do this in between steps. You can look at this slide if you want for an idea. Like I told you yesterday, 37. Yesterday's example was we were making a max heap by deleting 90. So once you have done that, you need to reorder your heap. Please reorder your heap. When you're basically going to reorder your heap, what you're going to do, you're going to compare 35 with 78 and 70. Okay. So whichever is the greater child, you're going to replace 35 with that value. So in this case here, you're going to have exchange these values. So 35 will come here, 78 will go on top. Then you compare again 35 with these two values. So you need to keep drawing those diagrams, separate diagrams for each of this. You compare 35 with 25, 35 with 46. So when you compare, you exchange with the larger child. When you exchange, you will exchange 35 with 46. So that means 46 will come here and 35 will come here. Are you all getting this? So when you do that reordering, this is what will happen. Are you getting this? So here basically what we have done is, we have deleted 95. Okay, are you all getting it? Are you all getting this thing after deleting 95? So once you have got this, your next step is, so when you delete 95, okay, please note that you have to place 95 at the last here in your array. Place 95 with the last index. Okay, and then when you renumber this heap, you will have only 10 elements. So you write down those 10 elements here according to these numbers that you have. So every time we are deleting the maximum value from the heap, we are going to store it at the index. So the largest value will be stored at the last index. The next largest value will be stored at index 10. Then third largest value will be stored at 9 and so on. Okay. So we are going to sort it like that. So at the end, we'll get the smallest value at index 1. So that is the idea behind sorting using a heap. So the next time you delete now 78, okay, now you'll have to now delete 78. Now when you delete 78, again, you're going to place 78 here, okay, in index 10. So basically what you will do is, you draw your array again, So in index 11, you're going to write 95. In index 10, you will write 78. Okay. So when you delete this, you're going to copy 12 in its place. When you copy 12, you will get a tree like this. 12, and you will have left child as 46, right child as 70. Then again 46 will have 25 and 35. 25 will have left child as 23, right child as 9. Okay. 35 will have left child as 12. Similarly here, left child of 70 will be 18, right child of 70 will be 48. Okay. So now for this tree, you check whether the heap property is satisfied. Check both the heap properties, the structure property and the heap order property. Check whether it is satisfied. So when you check, you will find that the structure property is satisfied, but heap order property is violated. So you need,
Sir,
yes, yes,
the last node, which is 12, it's actually gone at the top, right? So it should be not there.
correct, correct. Yes, by mistake I put it there. Yes, correct. This
Yeah.
should not be there. Yes, yeah. So yeah, thank you for that. And so basically heap order property will not be satisfied. So you need to reorder this and make it a max heap. So now to make it a max heap, what you will do? Compare 12 with its children, 46 and 70, and put the greater of the child as the root and place 12 in its place. So you will first start by swapping 12 with 70. So 70 will come here and 12 will come down. Okay. Then in the next diagram, you're going to compare 12 with its children. Again, both are greater than 12. The larger child is 48. So 48 will come on top and 12 will go down. So this will be your maximum, wherein you will have 70, 48 and 12 here. Then you renumber this. So this will become 1, 2, 3 and so on. Just renumber this. Once you renumber this, you write down the new values. So now at 1 we are having 70. So you will write here 70. At 2 you are having 46. At 3 you are having 48 and so on. So once you renumber, to write down those new values at this position here from 1 to 9. Now we are having only 9 elements in the heap because we have done deletion 2 times. The 10th and 11th are the 2 elements you have deleted. First time you have deleted 95, that is there at the 11th index. Second time you deleted was 78, that is there at the 10th index. So basically that is what you have to do. So can you do it? It's a little bit time consuming. It's not difficult, but a little bit time consuming. So can you try it? So once you do this deletion and you reorder it, this is what you should get. So like I told you in that, here is where your deleted elements are stored.
Sir, excuse me, sir.
Yeah, yeah.
Sir, in exams, we have to just give the final array, or we have to show each step by step, sir.
You'll have to show the steps. You'll have to show the steps.
Sir, but it will be to dots, no, sir.
Yeah, it's a little
Okay.
bit deep. Can you mute yourself? Yeah, so basically what this problem becomes a little longer. So in case you're running out of time, you can directly show the steps like this. Okay, if you know what you're doing, then you can directly show. If you're having time, you can try to show all the steps. At least in 1 or 2 places, you try to show this sub steps, and then you can for the remaining you can try to show it directly because it's a little bit time consuming. So now you have to keep doing this till the array becomes sorted. Okay, so it will get sorted only when you have finished deleting this all the elements. So please continue. So now next step you're going to delete is you're going to delete 70. So now you're going to delete 70. When you delete 70, you're going to place 70 now here in the 9th index. So 70 will be placed here in the 9th index. And 70 will be replaced by 9. Then reorder this heap. Once you reorder, you will get the next maximum value as the root node. And you have to continue doing this till you get the entire array sorted. So now basically now you're going to compare 9 with 46 and 48. Okay. So when you compare 9 with 46 and 48, the greater child is 48. So you swap this, so you will get 48 here and 9 here. Then you compare 9 with 18 and 12. So you will see that 18 is larger. So 18 will come here and 9 will reach here. Once you have done that, renumber all these nodes. So you will get 1, 2, 3, 4, 5, 6, 7 and 8. Only till 8 because you have deleted this. Okay. Then rewrite this array elements. So 1 will be 48, 2 will be 46, 3 will be 18 and so on. So if you have done it correctly, you will get like this. Are you getting it, what I'm telling you? Are you all getting it, students?
Yes, sir.
Okay, students, I think I lost the network. So anyone is having any doubts in any of the slides, you can please let me know, okay? I can explain it to you. If you have understood, then continue this deletion. So next you're going to delete 48. So after deleting 48, 48 will come in this position here. Okay. And you're going to replace 48 with 23. So compare 23 with its maximum child and swap. So you will swap, you get 46 here, you get 23 here. Again compare 23 with its maximum child and you will get 35 here and you will get 23 here. Renumber the tree, so you will get this 46 as 1, 35 as 2, 18 as 3, 25 as index 4, 23 as 5 and so on, and write down all those values here. So when you write down, you will get something like this. So can you all continue and finish it off? If anyone has finished with deletion of 46, you let me know. I'll turn to the next slide so you can see the answer. Delete 46. As you're solving, you can answer attendance. Akhilesh, Abhishek,
So Abhishek left college.
Abhishek left college.
Yeah.
Okay, Aman,
Present, sir.
Aniket,
Present, sir.
Anjali, Anushka, Arya, Ashish,
Present, sir.
Athena,
Present, sir.
Avishka,
Present, sir.
Carson, Carson is not there. Cheryl,
Present, sir.
Chintan,
Present, sir.
Dipanjali,
Present, sir.
Dhruvi,
Present, sir.
Enid,
Present, sir.
Germano,
Present, sir.
Hayden.
Present, sir.
Hayden, did you get this?
Yes, sir.
Okay. Tell me now your new answer. After you delete 46, what you get the answer? Let me know.
So after deleting 46 now.
Let me know. Yes.
Hello.
Yes.
I'm Arya, sir. I'm here. I
Okay.
couldn't speak
Those
before.
who have not answered the attendance, please let me know at the end. Okay.
Okay.
So Hayden, have you finished?
Yes, sir.
Okay. Tell me what will be the new route?
Uh, 35,
Okay. Left child of 35.
25,
Okay. Then.
18,
Okay.
12, 23,
Okay.
9.
Okay. Correct. Yes. So this is what you will get. Okay. So continue. Then you can delete 35. So those who have done 46 now go to 35. Delete 35. So I'll continue with the attendance. Roll number 18,
Present, sir.
19, Joshua,
Present, sir.
Kaiser, Kashyap.
Present, sir.
Kashyap, can you tell me deleting 35?
I was absent yesterday, sir.
What you get? New route. Kashyap,
Sir, I was absent yesterday.
you were absent yesterday. Okay. So you will not understand anything. Okay, let's continue. Macwell, Macwell answer attendance. Macwell absent.
Present, sir.
Malikesh, Malikesh, tell me deletion of 35.
25, 23, 18, 12, 9.
25, 23, 18, 12, 9. Correct. Okay. So this is the way it will look. Once you delete 27,
So your voice is clear.
delete
So your voice
You're
was
going to
glitched.
delete 23. Okay. Uh, so you're now going to delete the last few elements. You're going to delete 23, 18, 12, and 9. Okay, one by one. Once you are deleting all this is the way it will look. You can check out if those who have finished and confirm your answers. Are you all getting this? Okay, I'll continue with the attendance. So, roll number 24,
Present sir,
25,
24.
24 present. Okay, 25 Sahil,
25 present, sir. Present, sir.
26 Afiro, 27,
Present, sir.
28, 29,
Present, sir.
30,
So 29
Present,
is
sir.
present.
29 is present. Yeah, I marked you present. Those who are getting here tick mark means they are absent. Okay, 33, 30,
Sir, 31 present.
Sir, 32
31 is present.
present.
Yeah, 32. Okay, 33,
Present, sir.
35,
Present, sir.
36,
So 36 present.
37,
So 37 present.
Ritika,
Present, sir.
Rohan,
Present, sir.
Roshni,
Present, sir.
Rutvi,
Present, sir.
Saish,
Present sir.
Samiksha. Saish is there. Samiksha,
Present, sir.
Samiksha,
Present, sir.
44.
Present sir. Sam present.
Who is this boy now? Roll number. Boy. Who was saying
So
present? Which
42
boy?
I'm present.
Okay, yeah, I marked you.
So 42.
Marked you, marked you. 45,
Present, sir.
46,
Present, sir.
47,
Present, sir.
48,
Present, sir.
49,
Present.
50,
Present, sir.
51,
Present, sir.
52,
Present, sir.
53, 54. Suyansh is not there. Tanay, Umang, Vibhuti,
Present, sir.
Present, sir.
Yash. Okay. Anyone who has missed out on giving the attendance previously, just let me know your roll number.
6.
Roll number 6. Yeah. Okay. Arsan is there. Okay. Okay. So coming over to this topic on Heapsort, have you all got it? How it is being done? Any questions? Please let me know if you are having any questions about this. Yeah, Siddesh, it will be in ascending order for max heap. Okay, mostly. It depends on how you do the programming. Because now, according to your textbook, when we started with the deletion, okay, when I started with the deletion here, 95, it said that delete the maximum element and insert in the minimum element. So when you do the deletion, okay, Okay, I was replying to Siddesh's question and lost the net. Okay, so Siddesh, what he was asking was whether it will be always ascending or always descending for this. So it is not like that. Okay, it depends on how you are doing the programming. So here in today's example, we said that when you are deleting, you are inserting at the end. You're inserting in the end. So that's why you are getting an array in ascending order. Okay, but suppose I would delete this value, say 78, and we insert in the second position. I could have got a descending array. It depends on where you are going to insert it as a programmer. Okay, so using a max heap, you could get ascending heap or ascending order array, or descending order also you can get, depending on after deleting where you insert in the array. Okay, so mostly we follow this, because otherwise it will be difficult for, if you are using the same array. Okay, if you are using the same array, then this will be true mostly, that array will be in ascending order for max heap and descending order for min heap. But if we could have used a different array, we could have used a different array for sorting. In that case, then both the possibilities are possible. I could have had ascending order or descending order using max heap. Okay. Yeah. So any more questions? In general, have you just understood about everything that has been told today, or was it a bit